Let's continue to talk about numerical distributions. We talk about the line chart and the scatter plot. They are using for the numeric attribute as well. But here we will introduce another diagram for that. So the first thing, we can kind of create like the bar chart for the categorical data for the numerical attribute. One thing is we have to group the numerical value. This we call binning. So the binning is counting the number of numerical value that's laying within range. So we call that the bins. The bins are defined by their lower bounds. So we inclusively. So when you have the bin, it's a range. So in that range, we are including the lower bound, but inclusive for the upper bound. So the band, each band you can think about is just like the interval. So for example, here we have some number here. We have those numbers. So one thing is, if you want to do the individually to know how many, the frequency for each number, that's okay too. But one thing is kind of if they are big range, so that's why you have too many groups. So instead to have each number, they have their own frequency, we make the range for that. So we kind of see this number, the smallest one is 163. So the greatest one is 185. So we can think about, we can start for the range. If we make every 5 is a range, is a bin. So we can start from 160. So you have 160 to 165, 165 to 170. So to 175, 180, 185, and 170. So each group, they are including the lower bound. So for example, this one, you are including the 160, but not including 165. So we can do one by one. So you see 188 is between 185 to 190. 170, yeah, because even they are here, so we are including the lower bound, right? So they are, the 170 will be in this group. So 189 to here. So then you can continue to see each one. 163 is here. 183 is between 180 to 185. So 171, 185, and 165, and 173. So that's why you see here we have the group for each, the group for the data, for some specific data. So now the interval for each bin actually is 5. Let's see the demo. So we back to the top movies. So we using that table to do the numerical distribution. So this one we are thinking about the age. So do you remember we say on the top movie, so like the Gone with the Wind will be a long time ago. So instead using the year they produce, we're using the age when they produce. So what we can do here is age, our current age, that's changed to 2024. So the top, so we're using the top movie column years to minus each other, so we got the age. So then we add the ages column according to the array we get here. Okay, so then we show the top movie again. Yeah, I just restart my kernel. So here you will see that's the top movie. Also again, like we said, that's changed to 2024 minus the years. So that's our top movie. Also that's the ages. So in these top movies, we total have 200 movies. So we want to see in this 200 movie what their distribution according to the age. So that's why here even there are numeric data. So later we will show how we will group the interval into the bins. So the first thing that's the minima and the maxima for the age. So they are between 7 to 103. So we just kind of give them some the bin range. We do the 0 to 5, 5 to 10, 10 to 15, 15 to 25, 25 to 40, 40 to 65, 65 to 100. Okay, so that's display. So here our new table. Okay, so we're using the top movie. Okay, so the bin here, you have bin function. So according to your age, so we give them the interval. So your bins is an array. You tell them the range. Okay, so then they will create. You can see here. This is the bin for the range. So that's the age count. So just like our bar chart earlier, they kind of create the column for the frequency for each group for you. And so from here you can see for 40, this one have 59 movie. Actually, this interval is from, because we have the minima, we're including the minima. So the age is between 40 to 65. So between the 40 to 65, you have more popular movie here. So you will say why we do different things, the interval is different. So later we will show you why. We just want to give you the comparison how they look like. So if you want, yeah, we can do the interval with the bin with the same value. Okay, so here you can create another bin, the age. So this bin we're using the NumPy arrange. So we start from 0, okay, to, because this one, yeah, our top is 103. So let's do maybe 126. Okay, so we use the interval is 25. Yeah. So you will see here. So that's the count. So this one, the bin actually they were with the same interval in between. So here is the frequency between two different bins. So they are still displayed as a table. So later we will show you how to make that become the chart. But before we do that, let's talk about the area principle first. So what is area principle? We see this picture. So you will have better understanding why. So this picture actually show you for the new iPad, they have more battery power. So the quotation actually they showed you the new iPad battery is 70% bigger than the previous iPad. Then they show you two diagram. So they say the new iPad is 70% more than the previous iPad. So what's wrong with this? Yeah, I'm not sure you see that. So I think the height, right, that's the mean, more 70% more. But the issue is sometimes the commercial want to show you how powerful it is, but actually it's the wrong representation. Because for you, you will feel like, oh no, this battery is more than 70%. So that's why they want to attract you in the commercial, right? Because they want to show you, oh, how powerful the new battery is. But it's the wrong representation. So you really want to show the 70%. We have the height is 70% more. But the trick is the width here, the new iPad actually have the bigger width. So the area is now really is 70% more. So that's what we call the area principle. So when you want to show in the diagram, we are compare the area. We are not only compare the height only, unless your width is always the same. So that's what we call is the area principle. In your bar chart specifically, or in your diagram, if your area to represent some data, areas should be proportional to the value they present. For example, if you try to present 20% of a population is the one triangle. So then, right, 40% will be what? Right, you have twice triangle. But how they do? They try to show you in one triangle, and they make this triangle actually the other side is double. So actually, you know, the area is double become double times double. So then they are 4 times. So this one actually is the 4 times more than the 20% here. So this one actually is 80%, it's not 40%. So that's what we call the area principle. So after you understand the area principle, then we see how to draw the histogram. Okay, so what is a histogram? Histogram is displays the distribution of numerical variable. they kind of using the similar to bar chart, but it's for the numerical variable. So one bar represents one bin. So earlier that we say, if you want to using the kind of like the bar chart for numerical variable, you need to group your numerical data. So they need to use the area principle. The area of each bar is the percent for that individual group in the corresponding bin. Okay, so this one actually is not really like the bar style. So this one actually is later in this course, we will approximately histogram by smooth the curve. Area still is present for the percentage. Okay, so let's see here the histogram. Let's show you how to make the histogram, then we talk about more. So like earlier, our bin is this one, is not the same interval. Okay, so then we have our bin data, you have your frequency for each interval. So this one, try to make a table for that. So we add the column. Actually, instead using the count, how about we just convert to the percent? Okay, so we have the percent. So each percent is using the count for each interval divided by 200. So here, the 200 is total 200 movie in our top movie. Okay, so then we see again. Okay, so then we have our percent. Now we have our percent add to each bin. Okay, so how to make the histogram? That will be similar to the bars. So we have our top movies. Similar to the bar, but we change to the histogram. So then we're using our age as the x-axis. So then you just need to tell them for your bin, so what your interval is. So earlier we have our my bin, we use this one. Sorry, this one. Okay, so your bins is equal to my bins. Then we tell them what is the unit. The unit for the age is years, right? So then we do the year is the unit. So we see how the histogram will look like. Okay, so that's why you can see here, each bar is not different, not the same width. The reason is our bin earlier is not different, the same width. But here the y-axis is what? The y-axis is percent per years. Like earlier we say, each bar, the area represent your frequency. Okay, so we see here, you see for example 5 to 10, the percent is 9. So that's why here your width is 5 to 10. So you have 5 years. So then these 5 years share this 9%. So on the other hand, your height will be the 9% divided by 5. It's kind of 1.8. Okay, so the same thing. On this one, you will be the 40 to 65. So again, it's the area here is 29.5. So the height is percent per years. So the height actually is the percent per years. It's kind of like we say the density. It's the rate. So we can see actually in this interval, in this 40 to 60 years age, each year they have the last movie than the previous interval. Okay, so this one actually is the bin we kind of in different size of the interval. So you will say, how about we using the same interval size? Yeah, you can do that. So we do here. Okay, so how about we just make that from 0 to 110. So our interval is 10. So then you just make the bin is the another array we create here. So the unit still is year. Okay, so then you will see they look like this. What is the benefit if you have the same interval for each bin? So that's why you can see what is the benefit if you have the same interval? Also, the good thing is at least this one is every 10 years. So we can see these 10 years, actually we have more popular movie in that 10 years. So also you can have the without the bin you specify. So that's here is we have the default Python choose the bin. So then you can see actually we not really know what is the interval in between. So it's kind of dangerous to interpret the data. Like here it's not like you don't know it's 85 or 87, 83.